Welcome back to Fix It Friday. Today we're going to be talking about current tracers. These are pretty rare, but they're extremely helpful for solving some of the hardest issues that you run into with troubleshooting logic. This is the best one. This is the HP 547A current tracer. They are expensive, but they are worth the money, I promise you. So let's get started. We'll talk about what you can do with this little magic wand. Now, the most important thing you need to know about this current probe is that it only measures the current in AC circuits. So that can be the pulsing that's coming from the clock. It can be a pulse that you have put in with a signal generator or a logic pulser, but it has to have a pulse to read the current. If you're trying to measure a DC circuit, you're not going to get a good reading if you get a good reading at all. So it's very important to make sure that you do have a signal of some sort flowing through your lines. Also, the controls are really simple. You have a wheel knob that allows you to select from 1 milliamp up to an amp. Now, probably the first thing that you'll notice that this probe is good for is comparing the workloads of these chips. And the way you do that is you place your probe tip on top of the chip you want to measure, and you rotate your little thumb wheel until you get a light that just barely comes on. Then you move to another chip. Now you can clearly see that the chip on the left is drawing more current than the chip on the right. And that may be part of our design. The board may be working properly, but it may also be part of your problem. And that's for you to figure out. But I will say that it is very helpful to be able to buzz right down the board and see which of these chips are drawing more current than others. And if you're looking for a stuck node or a ground short, more often than not, this will lead you right to the chip that is causing the problem, because that chip will be drawing more current than all of the other chips like it. Now, where this current probe really shines is in a situation called the stuck node. And a node is a portion of the circuit where many of these devices will connect together and share a common signal. For example, the clock or one of the data or address lines. And those are good examples of nodes, but anytime you have two pins that are connected together, that's called a node. And what happens is one of these chips will die. They'll short themselves to 5 volts or short themselves to ground, and they'll drag the whole node down with it. And all of your chips that are connected to that node will have the same value. And so it will be impossible to distinguish which one of those chips is causing the problem with a logic probe, unless you start cutting traces and realize, okay, the problem's over here, and then I'm going to cut another trace, and problems on this side of the trace. And if you've got a node that has 15 chips attached to it, it is a complete nightmare. So to demonstrate kind of what we're up against, I have my logic probe, and we have a stuck node right here. And I've looked at the schematic, and the address bus is connected to this memory chip. And long story short, this pin is supposed to be toggling, and it's not. But the problem is that pin 2 of this memory chip is also attached to pin 19 of the CPU, and it's attached to pin 11 of this addressing logic chip that we have here. So there's no way to know without pulling these chips out and testing them or cutting traces which one of these is at fault. So the first thing I need to figure out is, why is this node stuck? Is it stuck because one of the pins isn't working, or is it stuck because one of the pins is shorted? And the difference that you'll see is if it's simply one of the pins not working, you'll be able to inject a signal. But if it's one of the pins is shorted, you won't be able to inject a signal. And as you can see here, I'm injecting the signal on this end, and I know they're connected because I've done a continuity test. And you can see that pin 11 is not going high when I'm injecting the signal. So we know that either this chip, the CPU, or this chip has a shorted pin inside of it. And since we're looking for a short, we can do this with a power off. So I've gone ahead and removed my logic clip, and I've got my logic pulsar here, and we're going to inject a signal into here and see if we can trace it around this node. So we'll go ahead and start a pulse with our logic pulsar, and then we'll set our current to, see, it's just on, I'm going to set it just above that. As it leaves this, it's going to spread out, so I want to set it a little higher. And then I'm going to go over here to this node, or this chip, and see where it connects to the node, and that's 9, 10, 11. So pin 11's not really lighting up. So I don't believe that the current is going this way. So let's swap them. We'll go on this side of the node and stimulate this side of the node, 9, 10, 11. And we'll see if we're picking anything up on this side. And so I don't believe that the current is traveling from this portion of the node over to this portion of the node and being grounded in this chip. And since we did it the opposite way, I don't believe that it's going into this chip. So let's see if we can find it. 9, 10, 11 going into, we're getting some signal. We're getting some signal around the processor. So I'm going to go ahead and flip this board over, and we'll see if we can trace the signals just a little better here. Okay, so I've got the board flipped over, and I've got our pins that connect to the node marked out with these little pieces of paper to make them easier to see. This is our memory chip, this is our CPU, this is our address logic chip. So we're going to go ahead and stimulate the circuit like we did before. And we'll use our current probe to kind of trace it out. And trace goes here. It looks like it dives under the board. We pick it up back there. And that's taking me right to pin 19 on the CPU. So I'm really suspecting this is the problem, but I'm going to go ahead and kind of triangulate it here. So that's 9, 10, 11. And let's see if we have any pickup here. Very, very little. But if we go back over here, so we know that if we pulse here, the current goes here. And if we pulse here, the current goes here. So if we do suspect a problem, what we do is we pulse that pin, and then we see if we're picking it up on either side here, and we're not. So we know that all the current that we are sending this node is going straight down that pin, and that our CPU needs to be replaced. So the last but really important thing that this current tracer will do for you is it will find a short to ground. And any of you guys that have ever had to look for a short to ground, I know that you are really excited right now. Because it is so hard to find. It can be really infuriating to find a ground short. And this doesn't always pinpoint it, but it will give you at most 2 or 3 places you should look. And so what I've done is I've grounded my current probe and my logic pulsar to the ground on the board, and I'm going to inject a pulse at the positive lead on the board. And then I turn my current tracer sensitivity all the way up, and I wave it around the board, and just looking for hot spots, trying to figure out where the current flow is in the board. And it looks like it's a little dimmer in this area. So I'm going to turn it down until I get just a little twinkle, and I'm going to keep moving. So I got hot spots here, hot spot here, hot spots all in here. Okay, so now I'm going to turn it down just a little more and see what's going on here. Now this is where you kind of have to have a little experience. Now this will not really happen for you overnight, but it just start playing with it and you'll get it figured out. For example, this right here, I'm not that interested in this hotspot because I know that this is the ground, and any signal that I send out this way has to come back this direction to here. So I'm not expecting the short to be in this area anywhere. Also, there's an electrolytic capacitor here that will really light up. And let me tell you, just about every electrolytic on the board is going to light up. So sometimes you find you have to pull the electrolytic capacitors. Now, these little capacitors are not such a problem because they need a much higher frequency than your logic pulsar is going to put out. And sometimes you're looking for a short in one of these. So, so I wouldn't worry about these too much, but I would go ahead and pull these, especially if it's my first time. Pull the electrolytics. So back to what we were doing. I'm going. Let's see. Keeping on the power rails. We've got a few going here. So I'm going to go ahead and move over to this power rail and see what I can figure out's going on. I've got heat all the way down it, which was last time. Okay, so this one's, see how it's really bright here. It's getting darker as we get away from it. So I'm going to go to the far one and turn it down. You don't want to extinguish it. That's kind of important. But I'm going to keep, see, this rail's not doing too much, but this one is, and this one. So I'm going to work my way down this rail where it's pretty hot. And we'll see where this goes. And I'm going to say that my current is probably going over here to this capacitor. I'm going to ignore this for a minute. And I'm going to head in the direction where I think it's going. And I think it's thinning out over here. So I'm gonna ignore this. These chips seem to use a lot of power. So if I was using a short, if I was looking for a short in a chip, I might suspect these chips here. And then let's work our way down this way. Now I've lost it. I've gone down too far. So I'm going to open it back up just a hair. Okay, I think we got a good sensitivity rating here. I still feel like that this trace is running this way and filling this capacitor. So at this point, I would probably pull this capacitor. And that would give me a much more objective idea of where this is going. But I've also got heat going this direction. See, that's going back to ground. And I've got a hot spot there. And I've got a hot spot heading toward this electrolytic capacitor. So now I've narrowed it down to 3 problems. I've got current flowing this way. I've got current flowing this way. And really nothing else is having any trouble. So I do kind of have a hot spot here, and this is actually the problem. I've sabotaged this capacitor here, and you can see that it does have a pretty bright spot there, and there's no current flowing into this capacitor right here. There is into that one. There's not into this one. And see, you can look at these other capacitors and see that there's not that much current flowing into any of them. This one, remember, is flowing this direction. So, like I said, it takes a lot of experience, it takes patience, but I promise this is better than trying to locate a ground short with a multimeter. Well, I think that concludes my series on logic probes. But if you have any questions or comments, put them in the comments box. I'll try to get to them. Anything you'd like to see on the show, I need to know about it. Don't forget to like and subscribe. And as always, thanks for watching. And I'll see you next Friday.